I'm very happy to present to you today another part of the whole presentation about the digital workflow. My name is Marco. I'm a master dental technician working at Zirkonzahn since around 5 years, and I'm in charge about the external trainings for our customers and also for a lot of research and trials on real patient cases as well. And one of the parts I tried the last time is the immediate loading workflow, or a smart immediate loading workflow. And this kind of, new technology and workflow I want to present to you today in combination with a Dr. Holger Meiser from the States, from America. And this kind of presentation is a little bit, how I can say, built up from my last presentation last week. So who was attending to the last event knows a little bit about the digital workflow to use the Plane Finder and Face Hunter in the end to have all necessary data in 3D, to have the patient in 3D in your software to work with. And today we go a little bit further, a step further, and we concentrate us to the immediate loading workflow. A part of last week we will see this time as well, but mostly of the stuff is new for you. So I will present you Dr. Holger Meiser. He is a great dentist. Actually, he's German, but he works and lives in America, and he has a lot of experiences in the dentistry, including the implant dentistry, oral surgery, and of course, the cosmetic dentistry. And it's really, really nice to work with him because he has a lot of knowledge and to develop our workflows better, to make it easier for you out there. And one part of this we want to present you today. And during the presentation, you will see also Dr. Holger Meiser in a video. He will explain to you a little bit about the patient case we did together. And we want to present you the immediate loading workflow. But before we start, I want to just give you an idea or information what we have new as materials. As you know, we have the Preto material since years on the market, and also the Preto anterior, the high translucent material as well. Last year we thought, okay, we have to do something else. We have to improve our material because the market wants to have material you can use for monolithic restorations, and that's why we created a new material called Preto 2. This Preto 2 combines the benefit of the Preto material and the benefit of the Preto 4 anterior material. So we have now a material is really strong, so you can use for any kind of cases, for any kind of indications, and also it's a really nice translucent material, so you can do a minimal layering of porcelain, or you can use it as it is, as a monolithic material. It's really, really nice. I will show you during the presentation or during the Facebook event as well, because I use this material for the patient case. And what we have else is the Preto 2 dispersive. This material is a multi-layer material, but the benefit of that material, you don't see the different layers or the different colors or layers of colors. We have a really nice transition of the colors from dark to bright. Also, this material is to use for all indications, from the smallest inlay until a full arch bridge. And here's small examples for you. This is a bridge made on Preto 2 dispersive, the multi-layer material. What I did here is just infiltrated the gingiva area with our color liquid and made individual infiltrations here in the incisor areas to have a nicer or individual effect after the sintering process. But what I want to present or to show here is that the whole tooth area is monolithic. So there is no reductions, no space for porcelain. So I keep it as it is, and I use it as a monolithic restoration. I just put a little bit of porcelain at the gingiva area, and the teeth area is just staying in glaze. And as you can see, the translucency and or the opacity of this material comes really close to the natural situation, to natural tooth. It's a very, very nice material. And also here another example, also here just stained onto the surface. There's no layerings with porcelain at all. It's a very, very nice material. If somebody wants to use or still wants to use porcelain, this is not a problem at all. I have a really, really nice smart workflow for it, because in my opinion it's really hard to build up the whole tooth of porcelain. But what is when we just make a small reduction at the incisor area? Yeah, only a small, like 0.2, 0.3 millimeters, and also with a mamelung effect. Yeah, so you can do that as well. And the most important information of the tooth, they will stay there. You will not erase them, reduce them, and build up again with porcelain. No, they will stay as it is, and this is mostly then the incisor area, the Meiser and the distal ridge. What is just reduced is the 1/3 of the tooth. What you can cover later on with porcelain very fast, and you get the same result as you build up the whole tooth with porcelain. Here I made also small infiltrations, small effects, and if you want to make or have internal effects, then it's time before you build the porcelain onto it to make some small internal stainings. Yeah, it's really nice to use our 3D staining kit for that, based on porcelain, so it's a very, very nice effect coming through the actual porcelain you build on it. Yeah, so this is the final product. Just use enamel. Well, it looks like you build the whole tooth, the whole teeth area from the ground with porcelain. It's very, very nice effect, very clever. Well, next one is this. I just want to tell you, this is quite new. Also with the Predator 2 dispersive material, you are able to create veneers. Veneers made in Zirconia. Yes, you heard right. Yeah, so also here is a really nice situation, a non-prep situation. Here we designed the veneers and milled them out in Predator 2 dispersive. We made a small over texture onto the surface, and after sintering you get this effect. Yeah, you get a really, really thin veneer. It's only 0.2 millimeters thin. We have a special strategy as well to mill the borders very thin as well. And then it's time just to stain and glaze the surface, and this is the result into the patient's mouth. And of course we have also gluing techniques you can learn in courses. So when you come here, we have our new education center called the MDT. It's a kind of clinic where the dentists and technicians are able to come together and learn everything about veneers, from intraoral scanning, over designing, and gluing into the patient's mouth. Well, let's start with the actual presentation today. Well, what is the perfect workflow when we don't have enough information about the patient? Yeah, it's very, very important to collect all necessary informations, and we have the possibility to use several instruments to realize that, to get those informations, to get in the end the patient as a 3D patient in our computer to work with. This whole concept workflow called CDD, Computer Dental Diagnostics. Well, I prepared some topics for you. I will speak shortly about intraoral scans, then we go over to the registration process, then how we capture the 3D facial scans, then we go over to, well, there's a really important part as well to how I can create individual occlusion surfaces with a special device. I will explain it later as well. And then we come to the whole designing step. And afterwards I will also talk about the implant planner as well. Well, those are different steps you can also let steps out of this whole workflow. It's up to you. You're really flexible. You can work also part analog and digital. It's very, very open, very flexible system to work with. Yeah. So let's start for a second with intraoral scans. Here it's, well, a lot of people, they think, okay, I have a Zirconia or I have a free shape scanner. How is it possible to import into the Zirkonzahn system? Well, we are an open system, so you're able to import any kind of open or related open formats like STL or OPJ format. But you're also able to import original data formats like from Planmaker, 3M or Trias. So we have this kind of import functional systems as well to work with. But the most important part is that, okay, I think I have a small problem here. You're not seeing the presentation. Okay, that's not good. Hold on. So I hope it does work right now. Okay, I think that now does it work. I'm sorry, I just clicked something wrong, but nothing happened. We are just at the beginning. Okay, so I prepared those topics: intraoral scan, patient registration, facial scans, then record the mandible motions. Then we go over to the cut part. That means the whole designing process of our patient case, and I will explain you a little bit of the implant planner as well. So, as I wanted to tell you, the intraoral scans are a very important part of it. Yeah. So you're able to import any kind of open related formats like STL, OBJ format, that for sure. And also we have kind of import function for original data formats like Carestream, Trios, Tri-Am, Planmaker. So this is not a problem at all. What I wanted to explain to you is that we are able to work with intraoral scans. We are able to use the whole digital instruments we got from our markets without any problems. Also, when somebody says, okay, we have some issues with the immediate loading, like full arch, maybe it does not fit very well, we have a solution for that. We can skip those problems. We can erase those problems at all as well. Yeah, so it's really important to create a very nice base of our models, yeah, or intraoral scans. Here in that way, I really say it again, who's working with this kind of workflow, please scan the whole palate area of the maxillar and the tuber region. That has kind of mounting related or measurement related functions. Yeah. So if that is done, then we go over to the registration process of the patient itself. And as you know, we have a kind of device called Plane Finder. It's a part of the PlaneSystem to capture all necessary information of the patient. What is really, well, the basic information for us technicians, dentists, is really normal to have a certain midline and the occlusion plane information. But what is when we don't have that and we try to capture those informations? Well, till now we use the face bow, maybe you are familiar with the face bow, but we know that the face bow does not work very accurate, yeah, and you can do also a lot of mistakes in between. And also each face bow device is related to other landmarks, to other planes. And as you can see here onto the example in this picture, that we got every time with different face bow systems, well, different results, not only in the transversal axis, also in the horizontal axis. And this is a huge difference, a huge mistake. Well, the benefit should be for this kind of system that the work should fit in the aesthetic way and also in the functional way. But a lot of dentists, they have to grind, they have to adjust the restoration in a certain way. Well, why is it so? It's a little complicated. It's not really complicated to explain, but who was attending last week, they know that. If we have just small changes during the registration, like small degrees changes, or we align the whole registration to the articulator in the end, we every time change a little bit the whole registration and we got mistakes. As you can see here under the picture, the middle picture is tilted just a little bit. A lot of people, they say like 4, 5, 6 degrees or more, but I can say this is not huge rotations, it's just a half degree, and this makes already, or has already a lot of fact to our restoration during the whole designing process. And as you can see here into this example, the lady on the left side is looking to you like I look to you, like straight with her head. But on the right side, you can see immediately there's something wrong. And I can say the whole registration of those model pair is made, or especially in the maxillar, is made with the face bone. And as you can see, the posterior area is tilted mostly upwards, and the horizontal plane is also not very well. And you can see when I match now both pictures onto each other, the whole mistake. Yeah, and now try here to make a really good fitting restoration, mostly in the posterior area. Well, it's not possible. Also, the dentist has to grind, adjust the occlusion surface. And let's say the horizontal plane is also tilted a little bit, and me as an technician has now the job to make a crown into this incisor here. What I use is the other incisor here as a reference, yeah, so I can adjust the crown or make the crown as long as the other two this. But what is when I use this kind of situation right now, when I offered a lot of time and well, love in this crown, and I will send it back to the dentist and wants to glue it into the patient's mouth, then the situation happens is that the crown is too long, because if we tilt it back, then the crown would go longer, and the dentist has to adjust the length again. And that's why we thought to make something new, like a new workflow, a new system, to have a kind of unique and reproducible workflow as well. And it's really easy to use this kind of system, and to use also in a universal way. Why universal? I can use it analog and I can use it also digital. So in the end, we provide for you a kind of face-bow system or registration system can be used digital. And it's really alive, what I mean with that, because I can collect all other informations from the patient, like X-ray or facial scans, and I have a better diagnostic for that. Well, in this kind of registration device or workflow process called PlaneSystem, yeah, this system combines the plane finder and the articulator itself. So what we can do with this kind of system, we are able to register and transfer the individual maxillar position into the physical articulator or the digital articulator in our software. And we are able to restore a missing or wrong occlusion plane. And this is, wow, this is a huge benefit. You will see that during the presentation as well. Let's start with the whole registration. You know, face-bow, articulator, they are related to certain planes. We don't use those planes. We use the natural position of the maxillar and transfer into the articulator device one by one without any changes. And how we can do that? We use a special reference, and this reference called natural head position, short NHP. And the head position does work in this way, as you can see in the picture. It's a really a funny movie actually. You see the chicken, or chicken's head is not moving at all, it's quite stable. Also when a person is shaking her body, the thing is that the chicken is fixing or looking to a reference to a dot or to an object into the room, and it's stabilizing her head in this way. And we as a patient or a human person, we are doing the same, mostly the same. Now I will explain you that how it does work. So we take our plane finder, our registration device, and this device is not attached onto the patient's head at all. It's standing free onto the ground, onto the floor, and we attached here on top a mirror. And what is the patient doing then? The patient is going inside this device and is looking themselves into the mirror in their eyes. And at this moment, the patient, they take automatically their natural posture and head position, obviously. And from this position on, we are able to register the head and transfer, because usually the maxilla is attached to the head, logic, and we are able to transfer via the head position, the maxilla position into the articulator device. How does it work? Step by step, shortly explained. First of all, we have to be sure that the patient can take any time or reproduce any time their natural head position. To control that, we use special angle, as you can see on the picture. So we put it here inside the plane finder, and this angle is an open instrument, so you can put a pin or a pen through, and via this, with this pen, we are able to mark the patient's face with 2 dots or a straight line regarding to this angle. And this helps me to understand if the patient would go out from the plane finder, go inside again, if those dots are still straight or they are not anymore straight, they're a little bit tilt maybe the head is tilted a little bit more down. That is the indication that the patient cannot reproduce the head position. So we have to check that. Otherwise also here we can make mistakes. So the patient has to take their head position minimum 3 times in a row, and then we have 2 possibilities to catch this head position. The first workflow would be the manual workflow. This is not the content for today. We will talk about the digital workflow. The digital workflow is in combination with our facial scanner called Face Hunter. The facial scanner is just a device to make of the patient's face a 3D photo, and this is how does it looks. And how we can use it now in combination. So first step of all is to control the patient's head position, as I explained you 2 minutes ago. And then we just place the Face Hunter in front of the plane finder, and we are able to capture now the individual head position, and via those scan markers here in the front, we are able to transfer it one by one without any kind of rotation changes into our system. So this is how it looks. Yeah, this is now the head position, and we use this kind of registration later for our mounting process into the articulator. And also this device, this is now the slide for it, so we are able to transfer one by one here also into the articulator. We are able now to mount the patient with the head position. So also this device is also a nice device to make the 3D facial scans, obviously. But I want to tell you is that this kind of situation here on the right side is not a really important facial scan from my side, from my opinion, during the whole modulation design process. I need emotional photos like smiling, like onto the left side, or like a bigger smiling, because then I have more information about the patient's smile line, lips, and I have more information also about the aesthetic midline. I have the eyes, I have everything what I need, and also I can make a little bit more advanced, so I can take also other pictures like in a relaxed lip position. This is very helpful for me when I have edentulous patients, for example, and I have to replace the anteriors, then I know exactly how long the incisors should be, because the upper ridge of the lower lip will help me to indicate the position. And it's a little bit overdosed here with that photo. You can do that. In my opinion, it's not really necessary to have a wide open mouth, but you can do any kind of photos you want to or you need. And now we come to another question. The question is how to register, how to match the intraoral scans into the 3D facial scans. And this is a really big question. We don't use gingiva or teeth or whatever. No, we use a special fork, a special instrument to make this kind of matching process, registration process very, very accurate. And this is the digital transfer fork, as you can see on the picture. And the fork has a kind of plateau where we can squeeze silicone on it, and on the front we have scan markers. So what is the workflow? We squeeze silicone on it, we put it into the patient's mouth, and the patient bites onto the fork, and we do a 3D facial scan from that situation. And that's how it looks, okay? But that's not it. So we have to go a step further, and we have to rescan the whole fork with our desktop scanner, with our table scanner. It means we scan the whole impression of the upper teeth you can find into the silicone, and we scan the whole scan marker area. So what we can do now is we register the fork onto the upper model via their impressions, and then the software will use the upper model and the fork and register everything into the facial scan. So now we have a correct placement of upper and lower into the facial scan. So, but a lot of people, they say now, well, this is not a whole digital workflow because I need still the fork as a physical object to rescan it to match everything later on in position. Hold on. We have a solution for that to complete the whole digital circle because we have this kind of cover. And this cover allows me to slide it onto the fork, but not anymore onto this fork. We have now, and you can just buy now this small fork, this shorter fork, where you can slide or put the cover onto it. And now, what we're doing now with this kind of combined instruments, the dentist is able to scan the whole fork with their intraoral scanners. So also, if a doctor based in the States and the technician is based in Italy, for example me, I don't have to wait anymore until the fork arrived via post. Yeah? So I can start to work immediately after I receive all necessary data via email. The workflow is similar. I just put the cover onto the fork and I squeeze again silicone onto the fork. And then we put it into the patient's mouth and we make a 3D facial scan as well. And later on, we take the fork out, and now it's time for the dentist to scan the whole fork with the intraoral scanner. And thanks to this surface, this haptical surface of this cover, the intraoral scanner is now able to read this kind of surface. When he's done, then the dentist has to go over the ridge, over the curve, and scan the impression of the fork. Or what I did here in this example, I replaced the fork into the patient's mouth and I scanned a part of the teeth, the upper teeth. It's also a possibility. And when the dentist is done, he will send everything via email to me into the lab, and now it starts to complete or to match all informations together. And here is also similar. I just match the fork into the facial scan and then the intraoral scans onto the fork, and I have the same result. I can find the upper and lower jaw perfect related, perfect position to the facial scan. And also now we come to the next question. The next question is, to use certain articulator parameters or the articulator itself to create dynamic occlusion surfaces. Yeah? But as you know, the articulator is a kind of static device, and I can adjust the parameters on their condyles in a certain way. But what is if I get, or when I can receive individual parameters for that patient to adjust the articulator? Or use, I will show you later, use this kind of device in a digital way as well. Let's start. This is the device called Plane Analyzer. This is a recording device and diagnostic device for the motions of the lower jaw. And as I told you, this kind of device is a diagnostic device, so I'm able to see if the patient has any problems in their movements, yeah, in their condyles or whatever, to realize, oh, maybe it's better to start right now with a bite splint treatment, for example. And well, if nothing is wrong and I just want to use the movements of the lower jaw, then I can use it also as a recording tool, as a recording device. And I have also a centric tool included. That means I'm able to find the perfect position, the centric position of the lower jaw related to the upper. And we figured out, or we provide for you a really secure workflow in combination with the plane finder as well. Yeah, because this is also a kind of device you attach to the patient's face or head. You don't have really registration landmarks, but we are able to register the whole patient with their natural head position, in their unique head position in that device, to start the whole recording workflow very accurate. So, and how does it work? So as you can see now much better here into this picture, this device is split in two pieces. One piece is attached to the patient's head and the other is attached onto the lower jaw. And well, and both parts are connected via ultrasonic together, so if the patient would do now movements with the lower jaw, the upper part will record immediately those movements. So how's the workflow? I attach everything to the patient's head. I make registration steps of the natural head position. Yeah, this is the first step. And then I exchange the fork for the mouth for the lower jaw to attach them onto the buccal or the labial area of the teeth. So I have no contact to the upper jaw, so the patient is able to make free movements. So then I have a certain protocol. The patient is doing lateral protrusion movements, left, right, also protrusion movements, mouth open movements, and I see those movements immediately in real time into our software. Here's the protrusion, and if it's possible, also the retrusion. And after this kind of movements, the software is calculating for the dentist a kind of report protocol related to these movements, but displayed, shown in 2D. And here the doctor is able to see some anomalies, some dysfunctions of the condyles or in their movement itself, and realize, understand, okay, I have to adjust this part with a bi-splint treatment as well. Or I can use this kind of movements, and the software is calculating in the background specific parameters to adjust the articulator related to the recorded movements. And that makes sense because I'm not using the articulator device anymore as an average device with the average parameters. No, I can now adjust the articulator fully, to have a fully adjusted articulator to make nearly the same movements as the patient is doing in the mouth. And I can use those parameters for the analog articulator and for the digital as well. But what is if I don't want to use this kind of movements of the articulator? What is if we go a step further right now? And the step further would be to record those movements and save them as a 3D, how I can say, 3D movement. I will explain it in this way. And this kind of 3D movement called at Zirkonzahn real movement. So that means I can record certain movements, maybe also mastications, yeah? And then I save this real movement, and I can export the real movement and import in our CAD software, in our designing software. And here, as soon as I import the real movement, the articulator itself will disappear, and the software will use just the real movements are recorded with the plane analyzer. And look at that, I have a really good example for you. This is now upper lower jaw plus, I hope it does work right now, plus the real movement I imported. Okay. And I recorded beforehand the mastication. Yeah? I just gave the patient a chewing gum in this example here. And I can record the chewing and transfer it into the CAD software. So now a lot of people they will say, oh wow, that's really cool, that's really a benefit, but what kind of benefit has it? The thing is, I can create with this kind of individual movements, individual occlusion patterns into our restoration. And just to understand how does it work and what kind of comparison I have to the standard workflow is this way. This is now a tool setup related to the upper jaw, and the intrusions to the upper jaw or the contact to the upper jaw is just shown as red. And of course I have to cut those intrusions away, and I have the static function, yeah, to cut those intrusions away immediately, just as they are. And well, it looks like that. Yeah, a lot of people, they know that. Then I can use another step or another function. I can use the 3D articulator to create a movement with this articulator to cut regarding the movements, the intrusions away. But if somebody does not adjust the articulator in a proper way, he will receive this result. Yeah, he cut the whole occlusion surface away. He has to know to adjust the articulator, yeah, the protrusion, lateral protrusion, maybe also the condyle angle or whatever. And this you can receive by using the plane analyzer to have a better dynamic occlusion surface. Or if we would use the real movements, we can create this kind of a movement in digital, and regarding to the movements, I'm able now to place teeth in the correct position. And these movements are related to the patient situation. And I can also exchange the tooth placement to get, in the end, a better functional occlusion surface. It's a very, very nice device. Okay, let's go to the cut part, the designing part. And here I will start to just explain to you, it's very important for us to start every time with a prototype. It doesn't matter which kind of case we do, we start every time with a prototype milled in a resin. And here I just want to explain, because I have also another case for you later, to use an anatomic bite splint for that. Yeah? As you can see, this case, or this patient here, is a really hard bruxer. He lost a lot of tooth material, and there's not really clever to start with a final restoration. He is really better to start with a bite splint, because to adapt the whole situation, the new situation in mouth much better. What is the workflow? We have to capture all necessary information of the patient, intraoral scans with a new VDO, facial scans, also face hunter plane finder. And then if you are able to, or if you want to use it, of course, obviously you can use the plane analyzer as well. Then I have all necessary informations to start a new tooth setup. I just place, regarding those informations, the teeth in position. I have a facial scan. I have directly feedback how the patient would look with new teeth. I can make also adjustments. I have also my virtual occlusion plane, occlusion plane I reproduce, and then I just connect the teeth, adapt the teeth onto the model, and then mill this situation out as an anatomic bite splint. And this is milled in a polycarbonate material called multi-stratum flexible. It's a multi-layered material, and it's milled very thin as well. It's only 0.1 millimeters thin. Very thin. Everything fits perfect onto the models, also into the patient's mouth, and the patient's teeth are not prepped at all. Yeah, it just snapped onto the teeth, and well, now the benefit is that the patient can check, or the patient is able to check the aesthetic, the dentist is able to check the occlusion, fitting, and everything, and the patient is able to wear that for a few weeks, yeah, to adapt the new video in mouth, or to bring it at home and show it to their wife, and we all know the wives are the most influential people at home. I'm joking, but you know, only to convince or to have a self-convincement of this new situation in mouth is a very clever idea as well. So, and this is the final product in the patient's mouth, and here we go. The patient looks very good and can smile, can eat with this step-on smile as well. And the next case, very short explained, is a similar case. Yeah, as you can see here, the lady has also aberrated teeth and huge gaps between the teeth as well. Also missing teeth. So the idea here also, we start with a snap-on smile, but a lot of people, they ask me how to capture the correct video, but because we have a certain workflow with an instrument called equalizer to deprogram the muscles of the lower of the patient itself to not find anymore their original occlusion. And so we deprogram everything with this equalizer to find the correct height and the correct position of the lower jaw as well. And then from this point on, we fix it with silicone, we create a jig, and we transfer this kind of situation then into our system. We match everything together, we combine it with our facial scan, and then we make a new tool setup from this situation on. As you can see, patient looks very different right now, and it's built also in multi-stratum flexible. Here also very thin, 0.3 millimeters. Yeah, very thin. Fits onto the non-prep teeth. Very good. And I just want to skip that a little bit faster. As you can see here, it's very aligned to the smile line as well, and the patient looks completely different. Okay, so let's start with the actual case I want to show you, just a little information for you beforehand to understand the whole workflow. Okay, and let's start with this situation here. This is our patient case I did with Holger Meiser from America together. And the pre-op situation looks like that. As you can see, the pre-op situation contains implants in the lower jaw, also natural teeth with root canal treatments in the past in the upper jaw. It's not really worth to keep all those teeth and implants. That's why we thought to start everything from the scratch. And Dr. Holger Meiser will show or will explain you the whole case beforehand, yeah, in a short video. It comes right now. As you can see, also very long teeth, and we want to explain you from this situation until this situation in step by step. So enjoy Dr. Holger Meiser now in his video. I hope it does work. Okay, I have small technical problems here, but okay, let me explain this. Okay, as you can see, this patient had a lot of root canal treatments, and he had this kind of situation over 45 years. And I don't know how many hours, like a lot of hours he spent at the dentist chair and to like fix his teeth. And well, it wasn't really simple for everybody. But I think we did it very well afterwards, and I will explain you now step by step what we did. Okay, let's skip that. And well, I received any kind of informations from the doctor, like facial scans, intraoral scans, and well, also made everything with a plane finder to capture their natural head position, etc. And my job is now to do beforehand a tooth setup, yeah, because we use later on this tooth setup to make the prototype, to make the planning process with the implants, and so on and so on. But when I see this kind of pre-op situation, I think to myself, or I would say to myself, well, that's quite difficult to make a tooth setup right now because I don't have any additional information to do it very well. Yeah, because this pre-op situation is not very helpful for me. Yeah? So what we can do is to use the second function of the PlaneSystem to restore the occlusion plane. Because then I have something, a plane, an individual plane, occlusion plane, helps me to make a better tooth placement. So how we can do that? As we know that the occlusion plane is nearly parallel to the camber plane. So let's say that if we are able to capture the correct camber plane, their position and angulation, we're able to reproduce the occlusion plane. Well, the camber plane is a nice instrument or a nice information, but it's measured onto the patient's skull. So there's a little problem. There's skin in a way. So that's why we use not the camber plane, we use the alatragus plane. Alatragus plane is nothing else parallel to the camber plane, but measured onto the patient's skin. Yeah, and there are certain points we have to detect and mark, and this kind of plane in the end is, or with this plane I'm able to reproduce the missing occlusion plane. So I'm able to do that very easy in a digital way. So in the end I mark the patient's face, and then I have special measurement tools in our software to detect the angulation and transfer the angulation into that specific individual and virtual occlusion plane. And as you can see, the plane is not straight and the plane is separated in the middle. This has this reason because we measure this angulation on both facial sides, left and right. And we as a human, we are not symmetric, we are asymmetric. That means on each facial side is different as well. Each angulation of each quadrant is different. So that's why we measure both sides and transfer both informations into our software, and the software will give me now this kind of plane and place it perfectly between upper and lower jaw. As you can see, the posterior area is hanging down a lot, yeah, in the it's hanging down, and also the incisors are hanging up, so we have to, or we should place it more down, maybe more longer. Also here onto the other side as well. So this is a really good instrument to work with. That's why I ripped everything off, I cut everything away to make now, related to this plane, a tooth setup. So we go now to our tooth placement mode, and these indications here onto the plane will tell me the position of the teeth, the incisors, the laterals, first premolar, first molars. It's very easy to place some teeth related to this position, or related to this marks in position. And also, look at that, perfectly aligned onto the right and on the left side. The incisors are also long as we want, and the lower jaw is in perfect intercuspitation. Well, this kind of workflow helps me very, very well,
But till now in the modeling software, you would do the tooth setup manually, still manually. But if somebody know to use the modifier software, our latest cut software knows that this kind of software is doing, small problems here as well, is doing this kind of tooth setup automatically. So that means with just one click, I just wanted to show you, but I have also here, yeah, I have small technical problems today. I don't know why. Okay, now it comes. You can see. So I have now upper and lower jaw. I have this virtual plane. Everything is aligned very well. And as soon as I load teeth, the modifier software will place them in position or in a generic position between upper and lower jaw. And then I will tell to the software, please adapt the teeth onto this plane. And with just one click, I'm able to make then a perfect tooth setup, aesthetic and functional tooth setup related to the reproduced occlusion plane. I just choose the correct tooth shape in the end, and then I'm done. And obviously, I'm able to make also some modifications into the patient's mouth. So this is here the example. I can make this kind of modifications immediately in combination with the facial scans, so I can work directly into the patient's mouth and make some adjustings. And also we are so far that we are able to create a kind of facial animation between more than one 3D facial scan to make a really nice mouth movement. Yeah, it's a very, very nice tool as well. And let's go back to our patient case here. This patient case, a little bit, okay, this patient, I don't know what's going on today here. Okay, here we go. Okay, the tool setup done. I just designed the gingiva around, yeah, and that's it for the moment, because I want to explain you right now the whole immediate loading workflow. So I just make the tooth setup, just start with that to make also the gingiva design, and then I go over to the implant placement. So that's a part you can use. You can place also implants freely, manually if you want. It doesn't matter. I just want to explain you this kind of extra step, additional step with the implant planner as well. So the implant planner is a very, very nice tool, because we are able to import any kind of free DICOM data, X-ray data, and we are able to import any other 3D objects like intraoral scans, model scans, wax ups, facial scans, or whatever into the software to make a better implant placement. Well, this, what I did already here, I load the lower jaw and I match it in position. We have also a nice cutting tool, for example, to cut all the artifacts away. And also here, as you can see, we're able to cut the X-rays onto the model surface away to create a very clean working base. Then I just load other additional informations inside, like the upper jaw or the facial scans. Everything is in perfect relation, because we have a really nice algorithm in the background to do that happen. So I don't need to match them again, just match one jaw in the beginning and that's it. And then I place a kind of plane into my lower jaw to create a panorama view, and that helps me to detect better the mandible nerve channels. Yeah, and the mandible nerve channels, they will be selected, and I create a kind of digital nerve in this channel to see then how far I can place the implants to this nerve. We have a huge library of implants, I'll show you later, but what is to place implants without a tooth information? So to have tooth information like aesthetic and functional position information of the tooth, very necessary, and that's why we integrated a quick tooth setup tool as well to let that happen. And then we just place or choose the implants from our library, and very handy is it as well, we have already included the prosthetic type. Right? So you're not able just to choose the correct implant system with length and diameter, you can choose also the conical, parallel, multi-unit abutments, also with the scan marker onto it. So you place everything in position regarding the 2D view and 3D view, regarding to the bone density, then you choose the drill sleeves, and later on you just do, regarding to this digital placement of the implants, a guide, a drill guide. And this everything is implemented in the software as well. Very easy, very handy to use. We just block out the model, so all undercuts will be blocked out, so the guide will fit onto the teeth very well. And we draw a margin around implants and the area we want to fix the guide onto it, like here in this case, teeth. And the software will generate automatically this guide. We can also modify some certain areas, we can build up material, reduce material, smooth areas, we can cut out windows as well to control the position or the fitting of this guide onto the teeth. Well, and later on we just able to mill or to print the guide. So you do that in your way. The software provides you these two possibilities. So it's a kind of open software. In our case here, we milled the guide, very, very accurate as well. In the future, we have a stackable guide as well. That means a splitted guide, not anymore this kind of simple guide. But if somebody use the flapping method and also wants to reduce bone as well and needs a guide to reduce the bone, then we provide in the future this kind of instrument as well. So we have a splitted guide, one guide as a bone reduction guide, and then if you're done by that, you just put the other guide onto it to make the drill happen. So I will skip that because we lose a little bit time here, and we start immediately with our immediate loading workflow in that digital concept. So how does it work? How it's possible? Well, we use a kind of workflow called double milling, or called double milling. And what double milling is, I just want to explain you now the following steps. So as you can remember from the case previously, just make the tooth setup and the gingiva design as it is, and then I just have to save both parts, here in this example as a denture, and I transfer these dentures into my nesting software. And in the nesting software, I'm able now to activate a new function called double milling. And this double milling allows me to mill this denture in two parts, in two steps. Why I need that, you will understand in a few seconds. The thing is, this denture has no implant informations. There's no correct basal side of the gingiva as well. So this is just the denture, the tooth set up with the gingiva. This is step number one. I just place it into a material blank like resin, and the software will calculate the first part, that means the top part of this denture. And it's like 80% of the whole denture will or can be milled already before the surgery. Before the surgery. Or during the surgery. So I have also a benefit because I can start with the whole tooth setup days beforehand and mill it already to have it ready for the day of surgery. That means I mill already out, and that looks like that. The bottom part is not touched at all. And what you have to do is you have to leave it into the milling machine. Or if somebody wants to buy a new milling machine, we provide a kind of removable orbit with our new milling machine called M2 or M2 Dual. It means this milling machine has an inner orbit, as you can see, and this inner orbit has specific anti-rotation points to replace the inner orbit again in a perfect position if it's with some need to take it out. And well,
Then the doctor is placing the implants in position via a guide or without a guide. It does not matter. You are able to do it by your own, how you do it anytime. Here in this way we use a guide, and then we have to capture the implant position via impression, the conventional impression, or via a digital impression with an intraoral scan. That means we just screw the scan markers onto it, and then I scan the whole maxillar or mandibular area, and we transfer it back into our CAD software. Via the matching process, I'm able now to align new implant model to old gingiva model via the palette. We have also special instruments for you in the future related to some reference mini implants, but only to let you know for the future. And then we match everything together. And what I'm doing now is I just take my old tooth setup and I adapt it onto the implants. Yeah, I adapt it onto the implants. I adapt everything onto the new gingiva area to create a nice basal area. Make everything nice, clean underneath. Yeah, this is the only thing I have to do to cut the bottom part. The upper part I don't touch at all. It's just necessary to make the bottom part. I have now the implant interfaces, the basal area of the gingiva, and the screw channels. And all this information I just transfer back into our nesting software. And now I come to part number 2. And part number 2 allows me now to match the new situation with the screw channels and all this stuff onto the material block where it's already placed the already milled top, already milled denture. And everything works in an automatic way, so the whole matching process is automatically as well, via the top area. And then the software mills the part 2, and this is just the bottom area with the interfaces, screw channels, and the basal area of the denture. So, and that needs only, okay, it's depending on the implant or the amount of implants, but usually it needs just a half an hour to finalize that. And then just to cut it out, you finalize it with composite around the gingiva, and that thing does fit onto the implants very, very well. Because we do everything directly, yeah? So we capture after the implant placement, after the surgery, the whole new implant positions, and then we're just creating the whole fitting onto it, yeah? But I save a lot of time beforehand because I don't have to start afterwards with the tooth placement, with the gingiva design. I save a lot of time with that, yeah? And this is now the final situation. It's just wrapped a little bit composite around, that's it. Here also milled a multi-stratum flexible, and well, this is the prototype. And the final and this prototype does fit into the patient's mouth very well. And as you can see here onto this picture, I just matched the digital situation onto the onto the real situation the doctor captured via a photo, and everything aligns, fits perfectly to each other. And the final restoration is a little bit different, because the implants in the lower area were placed mostly in the anterior area of the jaw, not in the posterior area. So I got a little bit difficulties because of the lever, of the cantilever in the posterior area. So that's why I decided not to do a screw retained restoration in the lower jaw. I decided to make a friction retained restoration in the lower jaw. The friction retained does work like that you have to create a bar very parallel around, and here in this case I used Zirconia to mill it out, and onto it to get the friction between I designed and milled a friction sleeve in Technomate. This is a kind of really flexible soft PEEK material, and onto that it comes now the structure milled in another PEEK material called Technomate Mineral. It's a very, very strong PEEK material with minimal with mineral particles, and the whole shape looks like that I created thimples where I glue single crowns milled in zirconia, Predator dispersive, onto it. Yeah? The single crowns, individualized, sintered, and also glazed and stained, and they will glued onto the situation. In the upper jaw is a screw-retained zirconia bridge. Here I decided to make also a minimal label cutback, yeah, as I shown you at the beginning, only 0.2, 0.3 reduction with mamelung structure in it. And that allows me then to make a small internal staining and to cover this area only with enamel or transfer masses of porcelain. Yeah? This is the situation after sintering, and this is the final product then, only to layer a little bit of enamel and porcelain for the gingiva area. Lower part, the crowns are just stained and glazed and glued onto the structure, and then the gingiva area is wrapped around with composite. And this does look in the mouth, yeah? And the patient is, well, is quite happy to have this new teeth in mouth, and he's happy till today. And this is also a smart solution I want to show you in a few seconds to close the screw channels. Yeah, those are plugs milled in resin to close the screw channels in this way. Just let you know in a few seconds. I hope the video does work right now, because I got a video from the patient himself to explain his situation. Yeah, this is well, today my technique here, my technical part is limited. Okay, but well, we are over time anyway, so. But the patient is able to explain the whole story, and well, he is really confident with this new situation in mouth. He didn't realize it very well in the past. Only people like in the family just asking him, yeah, what's about your teeth? You never smile on photos and like this. And but really now he feels very, very confident and very happy with the situation. He shows also to take out the lower prostheses, and it's quite funny. Okay, for the last seconds, I just want to explain you that kind of case. I did recently this year in March in Atlanta with Christian Ledger together. He is a very good surgery for implants and the maxillofacial surgery as well. As you can see, this is the pre-op situation. The patient has some dentures in mouth. What is just natural is that crown here and those little crowns here to the side, but everything else is just prosthesis. And it was a kind of challenge to make a diagnosis and to create, for the situation here, to create a kind of try-in, because of the position of the teeth. It makes it a little bit difficult. But in the end, only to let you know, all the teeth in the upper jaw will be extracted then. But for me it was really necessary, because we use this kind of double milling workflow as well here, that I checked the aesthetic and the function beforehand. And for that I used again a snap-on smile, an anatomic bite splint. Yeah, as you can see, I just placed virtual teeth over the existing natural teeth and created a bite splint, and used the natural teeth as a retention to fix the bite splint onto it. We checked the aesthetic, we checked the occlusion, everything fitted perfectly without any kind of changes, and then I was sure to use the situation, to use this teeth now for the double milling process for the surgery. That means we did the surgery, and it was a really huge surgery as well. We did a bone reduction, we did also sinus lift. Yeah, it was a huge operation, the surgery. It was really informative to see everything, and we placed then the implants in position. Well, and then from this stage on, we scanned with the intraoral scanner the whole upper jaw, yeah, with the implant situations. Beforehand, I designed the whole tooth setup, and then I matched, as I explained to you before, the new implant model onto the old pre-op model. And then I adapted the tooth setup onto the implants, onto the gingiva, and milled the second part, because the first part I already milled before the surgery. So everything is milled out, wrapped around with composite to make it a bit nicer, and then everything fits onto the implants very well. And this is actually the same picture from or after the surgery. That means we are able to provide this way teeth in a day, teeth directly after the surgery, not any more teeth tomorrow or another time. Yeah? And that makes everything more efficient. It's a really clean workflow, and well, what do you want more? Yeah, it's a very, very nice workflow. Good. And then for my last words, I will explain about this kind of plug, this little screw to close the screw channels. Yeah? Everybody knows the effect to use when you have the screw retained restorations to close the screw channels with composite. Yeah, you see the composite, it fits not very well to the rest of the restoration, or the composite will fall out, or plug will attach on it. Yeah, because it's composite. Well, we have a smarter solution for that to close the screw channels very easy and yeah, better. We are able to mill or generate a thread inside the restoration, inside the Zirconia restoration. So we mill everything out with our milling machine. It's very, very accurate, very precise. And then we are able to mill also the plugs, the screws. And for that, we have a special resin blank to let this happen. And the screws will be milled out in your lab. So you do that in your lab, actually. So you don't buy those screws. Yeah? And you mill it with our milling machine. You can see it's very, very accurate as well. So, and after screwing the whole restoration onto the implants, the doctor closes the screw channels not anymore with composite. Now he just does use those plugs. He just screws them inside the screw channel, and the rest of the plug will be cut away, and the surface will polish only. So, and they fit very, very well, very tight, so no saliva will go in. You don't have to use Teflon, you don't have to use an extra glue or composite, nothing from that. But a lot of people, they ask me or ask right now, yeah, how to reduce or how to remove them. Well, we have this special extractor here, a special instrument for the dentist handpiece, and the top part of this instrument is very sharp and well, and you just drill inside the plug, and then the top part, the head part of this instrument will attach. Or will attach inside, so you can't. And then with the reverse motion, you're able to remove the plug very easy. And here the situation or an example for you. After screwing into the mouth, we use the plugs, we cut them away, we polish the surface, and you can see the color fit very well to the rest of the restoration, and also here in the lower jaw, a very, very nice example for you to see that. Yeah, here you have to look very, very precise where they are. It's a very, very nice, yeah. idea. Okay, a little bit over time, a lot of things to explain. I could also talk 2 or 3 hours about the whole workflows. In my opinion, it's very interesting, and I hope you found it interesting as well. And I say thank you to you all.